Okay, so just a short little organizational thing here. I'm going to start out with an introduction and to introduce a little bit about myself, talk about internal review board basics for those of you who are unfamiliar with some of the basics. Then I'm going to talk about research protocol and ethics, which most people don't think belong, with a statistics talk, but I think that's the basis of how I learned a lot of this topic. Then I'll go over study design, methodology, statistical methods, sample size considerations, data analysis, just the regular typical statistics information, and I'll conclude. So a little bit about my background. I've been an applied mathematician for about over 15 years, but I truly got to learn about statistical methods while I worked for the Air Force Research Lab in the Sensors Directorate, and I worked there for over 6 years in the RF Imaging and Detection division. I tested a UHF-VHF radar system on participants ages 4 through 75 to develop a non-Doppler biometric radar system. Okay, so that was kind of a groundbreaking thing. Nobody had ever done this before. And I developed the statistical protocol myself and designed the analysis. In recent years, I've been teaching math and statistic coursework for scientists and engineers, and I just wanted to share some of those lessons learned with you. Okay, a little bit about the IRB, Internal Review Board. So they basically try to minimize the risk to the study participants and make sure that the risks are reasonable, okay? And that's in anticipation to some anticipated benefits as well. So you always have to think about the risk versus the reward. And the IRB helps you do that. They make sure that the selection of the study participants are equitable, and they make sure to use the risk versus reward analysis to do that. They also ensure that informed consent is obtained before any study can be appropriately performed, and it needs to be documented and kept safe. The information needs to be kept safe for each participant. There are also many monitoring rules that are in place, mostly by the FDA and monitored by the Department of Human Services. And so they also are tasked, that this IRB board is tasked with ensuring that the principal investigators can monitor this data. All right, and then the most important, I think, is that they ensure the safety of all of the study participants and that the confidentiality and the information is protected. Okay, and all this information can be found in the FDA and the link that I provided below. All right. So every accredited research organization usually maintains an IRB. A principal investigator needs to submit some sort of research plan, and that's called the protocol, the research protocol, and an informed consent as well. This is what's submitted to the IRB board prior to a particular study. And some of the things that you need to consider is that you have to protect vulnerable populations if they are part of your study, which in my study, there were, because I tested participants that were children, ages 4 and above. I needed to ensure that the information that I collected was kept private and confidential. I needed to assess the potential risk to each participant, especially since I was going to be using a UHF-VHF radar. And it was pretty wide band. So that means that the wavelength of the radar was pretty long. Now, I don't know how many of you know a lot about radar, but if you have a cell phone or if you're using Wi-Fi, then you might know a little bit about radar. So some of the frequencies that I was using, this UHF and VHF, they're commonly used in, or they used to be used in a lot of cell phone technology, although now they're up a little bit higher. So my frequencies of operation were between 800 megahertz and about 2 gigahertz. So that's around the cell phone ranges for frequencies. But I try to ensure to keep the entire bandwidth. And I'll talk a little bit about why I made that choice in a little bit. The IRB also monitors the study design, and they ensure that the researcher performs a risk to benefit analysis. That's, again, really important. Okay. All right. So some of the questions that are commonly asked when you're in front of the IRB is the science that you're going to be learning from your study, is it going to be significant enough to be worth the risk, essentially, because you're going to be testing on all of these participants. And so is this research going to be worth the risk? How is the risk measured? Do you need to use vulnerable populations? In my work, in my study, we were able to use vulnerable populations, but it took about 2 years just to figure out if we could. Is your study a minimal risk? That's something that's really important if you're going to be engaging in a short study. And what are the most important practices? So these are some of the common questions that I get asked as an educator and as a researcher about the IRB. And so some of the lessons learned are, just to remember that you're an expert in your research, but it is your job to communicate your research goals and the benefits of your research to the IRB board. Okay, and that's the only person that can do that is you. And so you need to ensure that that the IRB understands everything that you're trying to that you're trying to communicate. And whenever you're talking to the IRB board, you can't see them as the enemy. You need to take good notes, and you need to revisit these notes often. And you also need to remember that not every study is the same. So you need to find similarities of your work to other studies, because sometimes they exist, and the IRB will definitely be looking for that. And organization and timelines are really important. You can tell when somebody is not, when a researcher is not organized, or if they haven't considered their timelines. Once you're being interviewed by the IRB board, they can tell pretty quickly if you haven't done your research. So I think organization and timelines are key. And I have here a few images just kind of to some of the reasons why the IRB is important. Here we have the Nuremberg trials. They're famous for a lot of experiments that happened in Nazi Germany, where they definitely did not follow the rules of ethics that we're following now. But that's an extreme example. But even recently, this triplet study as well, and you can click on the link. I hyperlinked it to the article. We in our history as well, even this story was done in the 80s. So even fairly recently, we've engaged in some questionable research ourselves. And so we want to remember that ethics is really important, and we need to consider ethics in everything that we do. And that includes considering ethics in even something mathematical like statistics, in my opinion, especially so. But I'm a mathematician, so probably biased. Okay, so I created this little slide basically because there are a few things that we kind of forget about our respective fields. for example, whenever we think of ourselves, we automatically assume professional competence, but we have to remember that we're not experts at everything. And research isn't done in a vacuum. It's done in something that has, that really requires an interdisciplinary team. Now, for me, it was really easy because I knew that my research would be interdisciplinary. I'd been studying the work for a really long time. And so I understood that I was not an expert in mostly everything that I was going to be studying. I was an expert in only one tiny little piece of the work, but I was interested in the research enough that I could understand that I wasn't an expert in everything and then I needed help. So professional competence includes that, understanding that you may be good at one particular thing, but you will need help for other things. Objectivity. Objectivity goes hand in hand with human rights, especially in an IRB study, an IRB protocol. And so we're going to talk a little bit more about that later, but what is really connected with those two things is, will my work advance science? Okay, so human rights objectivity is kind of tied to that, will my work, will my work advance science? Now, we have also facts versus theory. We have to consider those. We have research aims, and we have process transparency. Those are other things that the IRB board actually looks at. But all of these little bullet points here, I actually got from the American Statistical Society. Okay, and this was something that was prepared for statisticians. And so even though statistics is definitely a mathematical field, we always have to remember that it ties us to all of these bullet points that I've named here. And whenever you're engaging in any study, whether it's for the IRB or not, you always have to remember all of these particular points. And the underlying question for all of these points is, will my work advance science? And so because of that, some of the lessons I learned from that is know the IRB members and their roles, because each IRB member has a particular role to play. There could be a statistician in the actual IRB board, but they're not required by the FDA. So if you do have an IRB statistician in the board, that's great. But if you don't, then it's going to take a lot for you to convince some of the IRB board members to see if your study is going to kind of pass the test. And so you, again, I kind of wrote this this bullet point again, you need to remember that the IRB is not there they don't want you to fail, but they want you to consider every single aspect of the study. So take the IRB member input in the best light and do not be defensive. If anything starts out by being defensive, then that's just going to be a delay, and that's not really going to solve anything. Okay, IRB members are there to help you, so you really should listen to their advice. Also, do your research about past protocols, especially when you're dealing with interdisciplinary work, but even when you're not, because there might be other research scientists who have tried to work through protocols that maybe didn't meet basic qualifications like sample size. And so by contacting them, you never know, you might be able to together work out a protocol where sample size determination is allowed. And you want to make sure that you follow all instructions for the IRB board suggests. Otherwise, you're going to risk a lot of delays, and nobody wants that. Okay, so again, data security is a very important job of a protocol, and statistical design can help with that. You can randomize subject IDs. You can design a coding system that guarantees personal identifiable information is safe. And even the collection methodology can protect every participant and ensure the data transfer is going to be safe and confidential. So just always remember that, even if maybe you're not a statistician, if you are going to be engaging in an IRB protocol, somebody who with statistics experience can help you randomize and protect your data. Okay, so you want to also remember that for every participant, you need to educate them about your study. And that's part of the informed consent. And you want to ensure that everything is understandable for them. So you want to, I know that the rule of thumb at the IRB board at AFRL was, they told us to write at the level of 8th grade education. But that for my study, that wouldn't be okay. And so some of the rules of thumbs may not work for you. So just make sure that even if there are suggestions, particularly when it's to inform participants that might not work for your study, that you voice them clearly, but not in a negative way. Again, I've talked about confidentiality, working with statisticians to randomize the data collection, and don't collect information just in case you need it later. Never do that. That is probably something that I learned right away, because statistical sample size determination was one of the first issues that I had. I had a student for my study that was working on her thesis, and I wanted to be able to collect as much data as I could so that we could use in data for her study, for her master's thesis, but then also data for my work. And I thought that I could combine everything and do it all at once. And I thought that that would be more efficient. But according to the IRB, that was probably not the best use of the study. And you want to work in interdisciplinary teams to ensure that you're using the data correctly. So that was one of my first lessons learned, is to not try to do everything at once, because that may also automatically disqualify your study, number one. But also you need to remember the whole aspect of a timeline. If you're trying to be too rushed, you want to try to figure out why that is. And so what we ended up doing was we ended up making a very small study for my student first. We figured out if that became our feasibility study, and then later on we were able to add more participants. So again, sometimes when you're new, you want to kind of do everything all at once, just because that's kind of how maybe you've been taught to do things in a different field. But with a study involving human participants, you really don't want to do that. All right. So now this leads me to teams. Who can really help you with your methodology? Do you have the right equipment? Do you have the right staff? Do you have the right timeline, right? You know what you need. You know that you need members with superior qualification. You know that they need to be individuals that can maintain confidentiality. So integrity is going to be an issue. If you're going to be working with agencies like the DoD, you're going to need things like clearance. If you have sensitive information or areas where you're going to be working in that maybe requires a particular clearance, then you're going to need to think about these things. And so this should always be done before even starting your protocol, because assembling the right team can help you create that protocol. It shouldn't be done the other way around. One of the other lessons that I learned in this very long study was that I didn't have the medical experience that I needed. I was working with the NIH, and so I thought that was sufficient. I was working with a lot of medical researchers, but because of the vulnerable population that I had, I needed to have a medical monitor. And so that meant that somebody needed to be there who had medical experience with anything having to do with dosimetric measurements, anything having to do with radiometric measurements. And so I was able to find a medical doctor right away, but I really didn't think that I needed that. And it was because I was working with so many individuals who were basically medical researchers, but they didn't have the MDs next to their name. And so sometimes, you know, you really do need those superior qualifications. Those will always be best. That's another one of the lessons learned that I had. Okay. So as you can tell, there's no one size fits all. Even if you try to overestimate everything and try to cover everything all at once, there might be something you're doing wrong there. Or if you're too cautious, there might be something that you're doing wrong there. And so you have to be able to, again, go back and figure out if your goals have been reached by others the right way, okay? And so figure out if others have made mistakes beforehand. And one of those, that's where the statistics comes in. What is your population? Who needs your study? Who's going to be helped by your study? Who will it help? Why can't it be done better with you as the principal investigator and not with somebody else? Why can't it be done better by just doing a simulation, for example, and not risking any study subjects? What are going to be the outcomes? How much time will this take? Again, timeline seems to be a really important thing, and it is. And so I kind of, if I can get this to work, oh, there it is. I kind of drew out here a data map, but I didn't really draw any of the data. So I didn't really draw any of the arrows. And so you can have descriptive data, all right? So if you have descriptive data, then you can think about things like case studies, individual case studies, cross-sectional data, longitudinal data, ecological data, retrospective or prospective data. If you're thinking about analytical data, then you can break this apart into observational or experimental, okay? And so with observational, again, you can have cross-sectional data, case-controlled data, cohort data, longitudinal data, okay? So if you're not too familiar with some of these terms, cross-sectional data means that you're not considering anything that's, you're not considering time. You're considering everything in non-temporal terms. So you're not measuring the time when you're thinking about the data, okay? So not considering time. I'm not the best handwriter because I'm using my computer. Unfortunately, my iPad won't let me do this. So not based on time, not measuring time. Okay. Longitudinal data means that you're observing a particular subject over time. Ecological data, of course, this is over time. Ecological data, oops, sorry. I'm not as fast writing this with my computer as I normally am. Ecological data is basically, I don't want to say that they think that they're probably the best for descriptive data, but I have heard that they have thought ecological research studies are probably have designed some of the best descriptive data study designs. And so I would say if you have a descriptive study to look at some ecological studies. There's also retrospective or prospective studies. So these are all the type of studies. If you're going to have some sort of descriptive studies, if you're going to have an observational, then you would either look at cross-sectional case control studies, and cohort studies are more along the lines of medical studies. And again, we have the longitudinal study designs, which I was also able to engage in with my study, and which we'll talk about in a little bit. And then we have experimental, which has randomized and non-randomized, and you can find out a lot of information out there. And so these are just the different types of data that you might have. And so these are the different types of studies that you can research in the literature. And remember, you never know where you might get your inspiration, especially with interdisciplinary research. It's always good to always look through every type of study, because again, there is no one study design that will fit all for human subject studies. Another very popular study design to kind of look through in the literature would be something that's that has a clever acronym called, I don't know how you say that acronym, unfortunately, PCOP, because this is very medical based. And so the P means patient, population, or problem. The I is issue, intervention. The C is comparison. The O is outcome, and the T is time frame. So again, there goes that time variable again, or that timeline, sorry, not time variable, timeline issue again. Okay, so just with everything having to do with study design, and with thinking about the type of study design that you're going to choose, if it's going to be descriptive, if it's going to be observational, experimental, you want to ensure the IRB knows that what your primary goal is protecting the participant. Okay, that goes hand in hand with the science. And you want to remember to think about the participant first. They are not data. And never call them that. Don't see your study participants as data. Anytime you even let that slip, that might make you seem like a Frankenstein doctor, unfortunately. So always remember the participant. How will this affect the participant? Even when you're designing your statistical study, and that's something that I always teach my students whenever they're designing projects themselves, is the participant comes first. Think about how many scenarios, what ifs, that are important, but this can be kind of difficult for new PIs in particular, because they might not know the what ifs, right? And so those are the confounding variables, and that becomes the issue or the intervention part. And so I would add in something like confounding variable or unexpected variables here. That's how I would modify this. Okay. You always want to think about new scenarios and what can go wrong. Okay. Ask for help again, and that goes with the comparison part. Okay, and brainstorm with team members. That goes with the outcome part. Time frame, organize. Ensure that everybody in your team has the same goals that you have, to make sure that that you're going to be ensuring the participant safety, because that's the top thing that you need to ensure. Okay, so just a little bit of the federal regulations, just because, working with the IRB, you kind of need to know the federal regulations under Title 45. Study approval is subject to variation in the interpretation of federal regulations at each site, in addition to many other potential factors, including investigator-related characteristics, institutional standards, IRB structure and function, clinical expertise and reviewing committee, and individual ethical and methodological standards. So maybe some people with IRBs or with experience with IRBs are kind of scratching their heads and saying, well, that's never come up in any of my protocols. And so when I had my protocol, of course, it was testing with vulnerable populations. So it was scrutinized to the extreme, I think, in my opinion. It took 2 years just to get some of the basics approved. And on top of that, it was the perception. Now, something that I learned is perception is everything with the IRB, particularly if you're dealing with an IRB in the Department of Defense. Perception is everything. And so if you appear to be nonchalant about your study subjects, if you call them data, then that might to them seem as if there's something wrong with you as an investigator. And then that biases them. That biases the IRB. The DoD also has to consider things like security clearances. My particular study was done in an IRB range. I mean, sorry, in an RF anechoic range. And so it was a pretty large study site, but it was in a secure building. And so we had to make sure that everybody had easy access to the range, but wasn't going to be subject to seeing anything that they couldn't see. So there are going to be some institutional standards that you might not normally have to deal with if you're, let's say, in an educational institution and you're dealing with an educational institution IRB. And of course, the medical aspects. So with, even though even at that point in time, when my research was done, which is around 2000, it started out 2010. I knew that there were children that were using cell phones, and I knew that cell phones were radars in the frequencies that I was testing, and I also knew that the anechoic chamber that I was testing in was rated for frequencies of that frequency, and so that means that the only amount of electromagnetic radiation that my study subjects would be, everybody had to, inside the anechoic chamber, had to shut off their devices. The only thing that was active in my study was my radar, and it was much, much less the power of a cell phone. And we did, I wanted to write in my study informed consent that the study participants would actually be getting less radiation than they would normally get, because in a common household, you had cell phones operating at all times, you had Wi-Fi, you had even a wireless phone, a landline phone could emit more power than what we were emitting with our radars. And so I thought, well, why can't we say that? Well, because they said it hasn't been proven by numerous studies, which was true. I was able to dig up one study, but they said that was only one study done by one institutional IRB that they felt didn't have the right standards to what the DoD IRB standards upheld. And so, sometimes even if there is evidence that you're helping participants, you have to convince your IRB to, that your standards are up to par. And unfortunately, any IRB has that right. And especially if you're dealing with vulnerable populations, and there's nothing you can do about it. And so the best thing to do is to work with them. And it ended up that just in that work that I was able to do with them, I not only did I learn a lot, but I think I was able to inform a lot of individuals, about the importance of the study. And all of that was through communication. And that's how I was able to finally get it approved. But now comes the part that was the most difficult. Convincing the IRB members who had, I think, somebody that knew statistics, but he was a physicist. And so he saw statistics in a different way. And so this is where I think that I didn't have enough experience at the time to be able to show the IRB that my particular methods were adequate and that I had enough experience to be able to understand the data. And so one of the things that I actually was able to use was this Anscombe's quartet. Does your study involve just one variable, or are there multiple variables? And mine had 1,053 variables. And how do you visualize all those variables, everybody thought, and why is it that you need so many? And so if you have all these variables, why do you need so many study participants? And why isn't it better to actually work with something that is a longitudinal study instead first, and then go backwards? And so it's true, those were good questions. The different methods can apply in every single case. There are tests that's, for single variables that could address a particular, to see if a particular probability model fits the data, or whether a particular population parameter equals a specified value. If there's tests for different variables, for 2 or 3 or 4. You have to think about if the variables are categorical, numerical, if they're mixed. What is it about your data that that is unique? What is the homogeneity of it? And when you have so many variables, how can you visualize it to the point where you can convince somebody else that you need the additional participants? And because everybody thinks, well, maybe you haven't thought it through. Maybe you just need 5 or 6. And so that's when this is a little bit more about my research. So this is where a little bit of my mathematical experience comes in, because what I had to make them understand is that my data was paired. And so there are different methods for paired data. And normally with paired data, once you have 3 pairs, that's difficult enough. And so now you have so many more. Are you just using PCA, and what does that really say? Are you just using SVM, all of these methods that are commonly used for dimensionality reduction? Are you just using too many dimensions? What does it matter, right? And so I had to kind of convince that this is what I needed. I had to convince the IRB that this was what I needed. And so I was able to design a kind of simplistic model, and that's where the dosimetry came in. And so back in the 80s, it turned out, for my study in particular, somebody actually had cut up a cadaver. This was, I think, in the Army. They cut up a cadaver and they dosed it with electromagnetic radiation, and they figured out the electric permittivity values of all of the different tissues in the body. Okay. And so when you have all of these particular all of this information, I was able to explain to them, then you wanted to use it effectively. And so in order to be able to recover some of that information, I would need to find a system of equations, and that's why I needed so many study participants, because I needed enough, enough equations for the unknowns that I had. And that's how I was able to finally kind of get them on board that I needed, more than 5 participants. And so there are many powerful tests out there, but how can you teach, 10 years of mathematics and statistics training to somebody who just is a different, or math and statistics and physics training to somebody who just isn't, who went a different direction. And so the best way was actually to meet people halfway. And I was able to find that study for those dosimetry studies in the 80s by meeting a medical doctor, by knowing a medical doctor and working with a medical doctor who turned into a physicist later on, an RF radar physicist. And so he was able to help me kind of turn this into a simple elevator type of pitch so that I can turn this study around and get the subjects that I needed. And so a lot of time, even with these statistical methods that you may know just inside and out, how do you deliver that information to other people? Well, again, it's communication and working with the right team. So that leads me to sample size consideration. We have a lot of trade-offs. A large sample size is needed to achieve this high, preciseness score, confidence interval, a particular width of a confidence interval, but you might be missing the mark. And so, are there these type 1 errors, type 2 errors to consider, bias, accuracy considerations? Are there confounding variables that you haven't considered? Have you planned for the data loss? Have you planned for the time constraints to collect the data? Remember that this trade-off for sample size seems to be something that's underlying. Aside from the timeline, sample size seems to be one of the biggest things that we're trading off here with. At least that's what I found. So some of the lessons that I learned then was to make sure that you have a simple method for the sample size determination. So to boil it down into something like I was able to do, there's most likely somebody that can help you in the IRB board, but if not, you're just going to have to find somebody outside of the IRB. And remember that there is a difference between qualitative data and quantitative data research. And so different IRB members are going to have different research experiences that you may not understand. And so you need to figure out a way to kind of be on the same page. And so you always want to think about that trade-off, but then also at the underlying that, you always want to make sure that the study goals that you're thinking about are a benefit to the society, and to always say that to the IRB board. Okay, so I think I'm probably going overtime here. So, some common data analysis methods. Here we have, I just kind of made lists. Make sure that you're just not trying any other methods. Make sure to map the analysis methods that can be useful. Don't oversell the analysis because it could change right in the middle of the project. Always have a backup plan and know your backup methods. And so I kind of listed some common methods that you can, especially some parametric and non-parametric methods for quantitative data, some for categorical data. And I listed on the side there some of the research fields that you might find them in, so that if you need something to read to kind of get a sense of how to use them. But always remember that there's going to be unexpected circumstances, recruitment issues, time delays, unexpected cancellations, research funding shortcomings. So understand that it's not, you do need to establish a minimum and a maximum for your sample size considerations. And you're going to need to know if you have a sample size that's small, you're going to use a different test than you would if you have a sample size that's large. So remember to plan for those and show the IRB that you're planning for those. For qualitative research, again, it's fundamentally different than quantitative research, but also know that mixed data methods and mixed methods research is really becoming more sophisticated. And if you're going to be venturing in that route, you're going to need active researchers in that field for support, because it's changing. I mean, I myself was engaged in an educational study just recently where everything was changing almost daily. I was finding new papers. And so it's a very active field. And so you really need to know your community, I think, in those fields whenever you're engaging in those type of studies. And so my overall lessons learned: before engaging in any human subject testing, know if your research is worth the risk. Does your study need vulnerable populations? This should only be considered really for minimal risk studies or high impact studies. And in mine, I was able to convince my IRB that it was a high impact study. And it was able to be successful. We were just given the patent recently. How many subjects are really needed? Don't forget to think about bias, preciseness, and risk. Data analysis requires planning, organization, communication, and constant research. Don't forget about finding the right team members and performing effective training. And that's basically it. I think I probably went a little bit over, but hopefully we still have some time to answer questions.
Thank you so much, Dr. Miranda, for the informative talk. So I just had a few questions I wanted to pitch to you. So how long was the IRB approval process for your project? And is this a common timeframe for protocols with vulnerable populations?
So the total time, I mentioned different times, the total time was actually 5 years. And so that's a really long time. That's not normal, but I did have vulnerable populations. And initially, the initial first study did only take 2 years. And I think that was because I didn't have enough experience, and I was trying to cover too much all at once. And the IRB really didn't like that. And so I think that this isn't typical for normal situations. Again, this was in the DoD IRB. And so because of that, the labs had just a lot, you know, every month they had a whole big old long list of people that they had to cover. So I think that was another issue, that our time got delayed. So it wasn't all me, but it was just a whole bunch of different factors. But I think you should plan on, if it's something that involves vulnerable population, you should plan on about a year or two.
Thank you. So for our next question, how many, since you said you talked about you didn't have enough experience, I guess, so how many years experience did you have before developing the statistical methods for your study?
So that probably took about 3 years to develop the particular methods. And that was because I had to get so much input. I didn't have the right experience. I was so young, you know, getting my PhD, and I was awarded all this funding right away. And so I kind of just started running with it. And so it did take me about a good 3 years to develop the methods. And not necessarily to develop the methods myself, because I was using a lot of methods that were already in existence, but it was figuring out how to communicate to the IRB that my methods would work. And so I think that's what took the longest time.
So do you think that someone with little to no statistical experience can design a large-scale study without an experienced statistician?
I would say probably not. I know that I wasn't able to really do it. I had to get a lot of help. I was lucky in that, you know, I had a lot of support. I had a lot of people on my team who were right there and helping me. And so I think that that's probably why it was successful, and it was a really large study, and I'm glad that I was able to get the help that I did. But I think that a statistician, an experienced statistician, would have probably cut off a few years from the study.
So how is a research monitor selected, and is this typical for any study?
So I had to have a medical research monitor because all of my collaborators were non-practicing medical doctors. Even though I had a medical doctor on staff, he became a physicist, and so he no longer kept his medical license. And so because he was 73, and so because he no longer had his medical license, then I couldn't use him as the medical monitor. So usually if there's any indication that you don't know something by the IRB, then they will suggest a monitor. And so I think that, I was able to figure out the math, and I think that I had the background enough for the math and the physics and the radar and and with my team. But I think that the medical monitor required somebody that was really knowledgeable, and I just didn't have that. And so if you don't have somebody in your team that has superior credentials, they're not going to be, you're going to need to hire somebody else, basically. And that's what the monitor is.
So I guess that's all we had for questions. Before we end it off, did you have any last remarks to give to all our attendees?
No, just what I always remind my students is to always remember that your study subjects are not data, and that you need to always consider their needs before your study.